Recently, there have been publications arguing that climate change can be explained by natural cycles known as the Milankovitch cycles. The hope is that these cycles can absolve human responsibility from climate change. However, the Milankovitch cycles cannot explain the serious changes in climate that have occurred over the last century. The Milankovitch cycles are natural cycles that influence the Earth's climate change. However, these cycles are a completely separate process from human-led climate change. In the early 1900s, Serbian astronomer Milankovitch used mathematical theory to study Earth's climate and seasonality. He used geometry to measure changes in Earth's orbit and found that these changes can impact the amount of incoming solar radiation. Milankovitch discovered that there were 3 natural cycles that factored into Earth's varying climate. The first of these cycles is Earth's eccentricity. The Earth's orbit around the Sun isn't always a complete circle, but instead fluctuates between a circle and an oval. When the Earth's path around the Sun is elliptical, or an oval, it has higher eccentricity. When the orbit is circular, it has low eccentricity. When the orbit is highly eccentric, the Earth orbits 3 million miles closer to the Sun at one time of the year. During the elliptical orbit, the Earth is closest to the Sun around January 3rd, which is known as perihelion. At this time, the Earth is approximately 91.4 million miles from the Sun. In comparison, the Earth is further from the Sun around July 4th, which is called aphelion. At aphelion, the Earth is around 94.5 million miles from the Sun. This cycle between a circular orbit and an elliptical orbit takes approximately 100,000 years. This change in orbit affects the Earth's temperature and climate because during the highly elliptical perihelion periods, the Earth receives more incoming solar radiation. According to the NASA Earth Observatory website, the Earth currently receives 6 to 7% more incoming solar radiation at perihelion than at aphelion. However, during other periods in Earth's history, there can be as much as 23% more solar radiation at perihelion. Milankovich's second factor in analyzing changes in the Earth's climate deals with the Earth's axial tilt. This is also known as obliquity. This cycle lasts approximately 40,000 years and describes the tilt of the Earth's axis between 22.1 and 24.5 degrees. The axial tilt causes the Earth's different seasons. A greater tilt leads to more extreme seasons because the tilt allows each hemisphere to receive more incoming solar radiation during its summer and less during its winter. This leads to hotter summers and cooler winters. During these periods, the increasing heat causes glaciers and ice sheets to melt. On the other hand, a lesser tilt leads to cooler summers and milder winters. This has the opposite effect on ice. The cooler summers can lead to ice ages because the ice cover doesn't melt as quickly. This creates a positive feedback loop because a large amount of ice increases Earth's albedo, so more sunlight is reflected instead of absorbed, and that decreases the Earth's temperature. Today, the Earth's axis is tilted at 23.5 degrees, so right in the middle of the two extremes. The third and last Milankovitch cycle is called precession, the wobbling of the Earth. Due to the gravitational pull of the Sun and the Moon on Earth, the Earth bulges at the equator, causing it to wobble as it rotates. This 25,000-year cycle is known as axial precession and is measured in comparison to fixed stars. For example, today, Polaris is the North Star. However, in the past, the Earth was tilted so that other fixed stars were the North Star. Because of axial precession, seasonality is more extreme in one hemisphere than the other. Every 13,000 years, as the Earth wobbles, the hemispheres flip the time of year that they experience their winter and summer. These 3 factors make up the Milankovitch cycles. Using these cycles and their respective lengths, Milankovitch was able to calculate both past and future fluctuations in the Earth's climate. Milankovitch concluded that these factors caused the ice ages to occur approximately every 41,000 years. Milankovich's theories were not accepted until the 1970s, when the Science Journal observed deep-sea sediment cores and found that ice ages do in fact correspond with the different 41,000-year cycles that Milankovitch outlined. So as you can see, the Milankovitch cycles do work both together and separately to impact Earth's climate. However, this natural change in climate is still completely separate from the climate change that worries scientists today. The Milankovitch cycles only explain long-term climate changes, which occur over the course of thousands of years. However, that is not what's happening right now. NASA satellites have confirmed that in the last century, there has been no large increase in solar radiation due to the Milankovitch cycles. Therefore, there is another factor involved in the rapid climate change that has occurred in recent years. Scientists have established that the burning of fossil fuels over the last 150 years of human industrialization have released a large amount of CO2 into the atmosphere, greenhouse gases trap heat in the atmosphere, and that is what is warming the Earth. It may confuse some people to find out that in past ice ages there was also a recorded change in CO2 levels from 180 parts per million to 280 parts per million. However, unlike today's CO2 levels, which are the direct result of human fossil fuel use, these historic levels were the result of a natural feedback loop that regulated itself. The man-made increase in CO2 levels are increasing at too fast of a pace to regulate themselves. In the last century or so, CO2 levels in the atmosphere have increased from 280 parts per million to 412 parts per million. This is dramatically different from the CO2 variation observed due to the Milankovich cycles. Also, the Milankovitch cycles are not currently in a phase that would increase Earth's temperature anyways. According to climate.nasa.gov, quote, Earth is currently in an interglacial period, a period of milder climate between ice ages. If there were no human influences on climate, scientists say Earth's current orbital positions within the Milankovitch cycles predict our planet should be cooling, not warming. End quote. Although the Milankovitch cycles are an important and interesting aspect of our planet's long-term climate, they are not the cause of today's worrying climate change.